Both Addicks and Barker reservoir outlets experienced tremendous volumes of rushing water to control the drainage of the city. Both outlets have served Houston and the surrounding areas faithfully for over 60 years. The constant outflow and pressure that volumes of stormwater present on a year-in, year-out basis will start to create small, weak erosion pockets around the outlets where friction from the forceful flow of reservoir water is greatest. From this point, the eroded area around the drainage gates begin to increase, washing away the subbase around the outlet structure. Developed voids increase and make way for water seepage, which creates an underground flow of reservoir water. Numerous water seepage locations will continue to weaken and erode the soil, creating even larger voids, not only horizontal to the structure, but vertically as well, creating safety concerns for the performance of the outlet structure. Due to the urgent and compelling status, the Corps chose Uretek ICR, a soil remediation company that specializes in stabilizing weak base soils under heavy concrete structures using a special high-density, hydro-insensitive expanding polymer. After the first injection holes were drilled, Uretek operators discovered larger void spaces under the conduit that was initially suspected based on GPR results. Operators field tested the void spaces by inserting a 5-foot copper rod through the 24-inch thick concrete. Void probes showed 1 to 3 feet of void in many areas under the conduit. As the injection process began, large void spaces began to fill up along with densifying and reducing seepage. As the polymer is injected, it immediately starts to expand but still travels under the conduit to the path of least resistance, filling the void and densifying weak areas. With 2 Uretek teams void filling 2 conduits at the same time, the void filling process becomes more efficient, an asset to the Corps' goal to completion. The patented Uretek polymer expands and it is at 90% strength in less than 5 minutes, so when outcropping occurs in flowing water, the material will set up inside the outcropped hole quickly, wasting little material and creating little debris for landfill. The little material that is carried out by the current is easily captured with floating buoys. Even though the polymer is environmentally inert, the worksite is kept clean. As Uretek polymer is injected under the conduit, it aggressively seeks out void spaces and begins to tighten up the surrounding soils, bonding the strata together to increase the collective load-bearing capacity to support the structure above. The polymer quickly expands up to 15 times its liquid volume and is at 90% strength in less than 5 minutes. As voids are filled below the weakened structure, the polymer will travel vertically, filling voids along the sidewalls, restoring the entire structure's subbase, providing superior stabilization to the conduits and drastically reducing the chances of outlet failure. Army geotechnical engineers gather soil samples to determine the condition of the base soil that the conduit was built on. Samples taken on previous injection locations showed Uretek polymer was present under the conduit and was filling the voids and densifying soils. Material also followed void paths under the spillway slope as well, with a surprise appearance through one of the investigatory access ports, pushing loose soil and expanding through the hole. Signs such as more outcropping and tightening of the loose soil from under the conduit show big progress has been made to stabilize and fill the voids under the outlet structure. The Corps continues to monitor both outlet structures as Uretek works at the Barker location. The Corps opens the gates to the Addicks outlet station to continue relieving the Addicks reservoir of high water, an efficient plan that will pay off in case of an all too common heavy sustained rain that can cause another rise in floodwater that can threaten the city.